Hello everyone. Thanks for joining. I'm Shaman Carr, and I would like to thank everyone for attending this live session this evening. So I want to first introduce myself and our organization a bit more for those who are not familiar. I'm a junior at DuPont Manual High School here in Louisville, Kentucky, and I'm also the co-founder and CEO of the nonprofit organization called Community AI, which empowers high and middle school students to build AI-driven projects to help the community and the environment. Both in the club and Community AI, we seek knowledge from data scientists to talk about their experiences about how AI and data science in general are used to solve real-world problems. Today, we're very fortunate to have Dr. Willert, who's our chief advisor and mentor, who will talk about career paths in data science. I would like to thank Dr. Willert on the behalf of Manual AI Club and Community AI for taking time out of his busy schedule to join this discussion. We have most of the AI Club members in attendance, and also we have Shreyas, who's our founder and now a club alumni and mentor, who's joining us from Stanford University, pursuing a CS degree in the AI track. We also have our teacher and club sponsor, Mr. Lober, whose continuous guidance and support makes this a very successful club. We cannot thank you enough for your time and valuable advice, Mr. Lober. Without further ado, I will hand it over to you.
Thanks, Raman, for the generous introduction. Let's see if I can actually share my screen to introduce Dr. Willert appropriately. Are you guys able to see my screen being shared there?
Yep.
Okay.
Excellent. Okay. So yes, we want to say thank you and welcome once again to Dr. Jeffrey Willert, who really, for all intents and purposes, is the main force as the adult leading this cohort in this group. They just needed a teacher sponsor. That's why they pulled me in. But he is the brains behind everything that takes place in this organization, along with the student leaders, both Shreyas, who was the original founder, and Shraman, who's our current president. So just to give a brief overview of Dr. Willert's background, and I will let him fill in the details that I'm missing. But he started out with a BA in mathematics from the College of Worcester, and then he got his master's and PhD in applied maths at North Carolina State. He's worked in several locations, initially at the Los Alamos National Laboratory as a postdoc researcher. He worked at Altamira Technologies as a senior data scientist, and most recently is now in Louisville, Kentucky as the team leader for data scientists at Schneider Electric. I was hoping to find out everyone's geography knowledge. I don't know if we have a show of hands. I forgot what our icons are with this interface, but I'll ask Shreyas. Do you know where the College of Worcester is, Shreyas?
I'm not sure at all, but if I had to guess, I would go with North Carolina, but I'm not sure.
It is not in North Carolina. It's right there in the heart of Ohio. Is that correct, Dr. Willert?
That is correct.
Yes, you guys can see it there on the screen. Yeah, it's in the city of Worcester, which is about an hour south of Cleveland. Is that approximately correct, Dr. Willert?
Just about right.
Have you been back since you graduated?
I have.
Excellent. Well, you can fill us in on any of those details. I'd hope to give a little background and my understanding of AI and machine learning and the advancement over the last 30 years. But unfortunately, when I tried to go to my Cliff Notes, it said that ChatGPT is at capacity right now, so it wouldn't give me any information. All I know is that about 1990s, didn't AI mainly focus on symbolic approaches, but there's been kind of advancements with the development of deep neural networks, the DNNs, there's been reinforcement with some of the training models that we've had, and recent advancements have been approaches in, I'm not really sure what unsupervised learning, semi-supervised learning, or transfer learning explicitly mean, but I saw something in that regard. So I'm going to let Dr. Willert take over. We just want to say thank you to Dr. Willert for all of his time and effort and really spearheading this whole organization along with Trace and Schaumann, and look forward to a wonderful presentation. Go ahead and take it away, Dr. Willert.
Well, thank you.
And let me stop sharing here.
All right, let me see if I can share my screen. All right, is my screen visible now?
Yep, we can see it.
All right, great. Well, thank you everyone for the kind introduction. Thank you, Schaumann, for helping coordinate this. Thank you, Mr. Lobler, for the kind introduction. I'm going to actually spend some of my time kind of filling in the gaps there, telling you a little bit more about who I am. I think it'll be interesting to see that I've kind of taken a non-linear path into data science. That was never my goal when I graduated from high school or college or grad school. Data science wasn't really on my radar, but I found myself here nonetheless. I'm going to talk about what data science is, and luckily for everyone here, ChatGPT actually wasn't at capacity, so I used that to help me fill in some of these slides. I'll talk about what skills are important in a data science career and some of the different paths you can take to data science. And finally, I'll spend a couple minutes talking about the career outlook. So as has been noted previously, I'm a senior manager of data science for Schneider Electric. Schneider Electric is a really big company. I don't think that most people in the US have heard of Schneider Electric, but across the globe, it has a pretty big presence. It's a company that has about 140,000 employees and a market capitalization that's approaching $100 billion. I work in a very small organization within Schneider Electric called the Sustainability Business Division. I'll talk a little bit more about that in a few minutes, but I'll give you a little more background on myself. So I moved to Louisville in 2019 with my wife and 2 kids, and I've got 2 cats who basically just spend all their time hiding from the 2 kids. I really, truly love applied mathematics. Data science, machine learning, and AI really get me excited. At night, when my wife picks up a book to read, to wind down for bed, I generally start reading articles in this space. It's nice because it helps me along my career, but I also find it really interesting. What drives me in my career is sustainability and innovation. So those are kind of some recurring themes that have shown up in the last 5 years of my life. When I'm not doing data science, I like to kind of have a well-rounded life. I like running and cycling, and I like to play team sports. I just joined a soccer team. I am a very bad soccer player, but I'm competitive, and I like to go out there and have fun. And I really enjoy watching TV. So in fact, right before this talk, I got on my treadmill and ran for half an hour so I could catch up on some TV shows that I just don't have time to watch otherwise. So the College of Worcester is a small college in Worcester, Ohio, between Columbus and Cleveland. It's about 2,000 students now, but when I attended, it was about 1,800, so it is growing as well. When I attended, it was a fairly liberal arts focused university. It's still a liberal arts focused college, but over the past 15 years, their math and computer science departments have grown significantly and now represent almost 20% of the student population, which is quite impressive for a liberal arts college. When I was there, I tried to get involved in really everything I could math related. I was the math club president. I participated in modeling competitions and the Putnam competition. Shreyas, I'm sure you'll learn about those fairly shortly in your university degrees. And hopefully you'll score much better than I did in both of those. I helped teach linear algebra. I tutored, and I graded homework. Really everything I could do to get involved in the math department, I did. And then in the remainder of my free time, it was all about intramural sports. To answer Mr. Lobler's question, I do get back to the College of Worcester, and now I work with College of Worcester students every summer as part of one of their college internship programs. I provide a project that 3 students get to work on for 8 weeks every summer. So it's been a great relationship. I went to grad school at North Carolina State University in Raleigh, North Carolina. I worked pretty much entirely in applied mathematics. I kind of avoided the theoretical side of mathematics, aside from a few courses where I kind of had to get involved. And I focused on numerical analysis, algorithms, optimization, and computational physics. I had a really unique opportunity while I was there to kind of do a PhD thesis that bridged 2 departments and ended up learning a lot of nuclear engineering. So my thesis was titled Hybrid Deterministic Monte Carlo Methods for Solving the Neutron Transport Equation and K-Eigenvalue Problem. To make a long story short, I was helping model interactions between neutrons and the materials that make up a nuclear reactor. At the time, we were partnered with Oak Ridge National Lab and Los Alamos National Lab, who had received funding from the Department of Energy to develop new algorithms for modeling nuclear reactor dynamics. Basically, they want to be able to model nuclear reactors in really high fidelity to make them safer and hopefully reduce costs in their development, should we choose to build more in the future. And again, this is a recurring theme. I think it's really important. I encourage everyone to maintain a healthy work-life, education-life balance by staying active in intramural sports or running or playing video games, whatever you choose to do, whatever makes you happy. I really encourage you to do it. And that's something that I always try to make time for. So after grad school, I moved to Los Alamos, New Mexico, which also would have been a good quiz for Mr. Lober, next time. Los Alamos was a really interesting place. So for those who don't know the history, during World War II, the United States was working vigorously to try to develop nuclear weapons. And they were very concerned that other countries would try to steal that research. And therefore, a very large portion of the theoretical work and experimentation that went into building these weapons was done in Los Alamos, New Mexico. Los Alamos is 100 miles from Albuquerque. It's about 40 miles or 50 miles from Santa Fe. It's a small town in the middle of the mountains that is intentionally very difficult to get to. It's a town that still only has 10,000 people in it. And to kind of tell you about to give you an idea as to how remote it is, it takes about 30 to 40 minutes to get to the nearest Target or Walmart. It is off the grid, intentionally so. While I was there, I continued to develop algorithms for modeling neutral particle transport, both neutrons for reactor research and then thermal radiative transfer. These are some of the hardest physics problems that we try to tackle as a human race. They take place in some instances over very, very short periods of time that we're trying to simulate. Maybe 1/10,000,000th of a second. We're trying to understand the physics over an area maybe 2 centimeters wide and 2 centimeters across. So think on the order of 1 to 10 cubic centimeters, very small areas that we're trying to understand the physics at. And we wanted to focus on really highly parallelizable methods that could be run on next generation computing architectures. So again, as was noted a few minutes ago, AI has really grown a lot in the last 5 to 10 years. And part of that advancement has been thanks to the ability to do machine learning on what is known as GPUs, or graphical processing units. At Los Alamos, around 2011 or so, we were pioneering the use of these GPUs for physics calculations, including these Monte Carlo methods that we were using to simulate these physics problems. On the right is an example of an output from one of the simulations in my thesis, looking at, in this case, the distribution of neutrons in a nuclear reactor. You can start to see in some areas a little bit of the fine scale structure of the reactor. See if I can draw a little bit. You can kind of see some grids here forming. So this is a common test problem, and you can see that the solution is a bit noisy because we're using these Monte Carlo approaches, which basically rely on random number generation. So it's a really cool technique that I would encourage everyone to take a look at sometime, because it can be used to solve a lot of different problems. If I move on, there we go. After spending a few years in New Mexico, I moved to the Washington, D.C. area. I loved working at Los Alamos, but as I mentioned, it was very remote. And at the time, my wife was graduating with her PhD as well, and she wanted to teach. So it turned out that it just wasn't, Los Alamos wasn't a great place for both of us to be, but Washington, D.C. had a lot of opportunities. So that's where we went, and I joined IDA. And this was my kind of transition from pure algorithm development to applied statistics and optimization studies. IDA basically was tasked to perform studies and research for the US military and different DoD organizations. My group specifically used modeling and simulation to protect US service members from chemical, biological, radiological, and nuclear exposure. So I used modeling software and optimization techniques to increase safety, to understand different threats. And really, this is my first exposure to data science and my first exposure to kind of deep learning or neural networks. After a couple years there, I went to work for another organization in the Washington, D.C. area called Altamira Technologies Corporation. This was the first time that I had a role as a senior data scientist, really a data scientist at all. I later became a lead data scientist, where I led a team of about a half a dozen data scientists working on projects for the United States Air Force Chief Data Office. We worked on a variety of really cool projects, like matching airmen with optimal career paths based on their aptitude and interests. We worked on predicting how long aircraft would be able to fly before they needed to be retired, and also predicting when they would need maintenance. We did some what we call scenario analysis and planning for pilot career advancement and training, basically doing optimization to try to understand how to make the best use of limited supply of airplanes while still trying to grow the pilot population. And similarly, we had to optimize training schedules using a variety of data and requirements that were given to us by the subject matter experts. This was a great opportunity for me to learn more about data science and machine learning on the job. But it was also a great opportunity to develop some of the soft skills that I'll talk about later on. But I'll say it right now, data science requires both these technical skills and what I'll call soft skills, which are the ability to really interact with other people. Even if you do the best data science, it's meaningless unless you can present it to the right people who can make it actionable. Finally, I moved to Louisville in 2019, and now I lead the data science program within the sustainability business of Schneider Electric. And this is really where I want to be, working on energy efficiency, sustainability, and looking at the challenges that are going to plague society in this kind of energy and climate space in the 21st century. We are working on building a robust industry-leading data science and machine learning capability. We're working to improve the internal efficiency of our business, add what I've called AI smarts to our existing software and the services that we offer. And we're also working to build new AI-supported software to help reach new clients and deliver new capabilities. So one thing, I've shown a picture here on the right, just as a kind of basic example of some of the things we want to do. This is an example of trying to predict the next 24 hours of energy demand in Ontario, Canada. So this is actually kind of a challenging project because it depends on so many different factors. It depends on human behavior, understanding patterns of movement between people moving between work and home, the energy that gets used due to weather, things that vary by day of the week and hour of the day. So it's quite a challenging problem despite its simplicity. So I'm going to pause right there. I said I would take a little break in between sections, give myself a chance to take a breath. Shreyas or Shaman, do we have any questions that you want to highlight?
Yeah, I think we have one in the chat, which is the following. So I'm very curious to know how ChatGPT works, but its services are not available in my country. Do you know any means or simulators that can help me have a feel of the novel AI chatbot?
So I'm gonna maybe wait to answer that one towards the end, because I do plan on getting to the kind of new generation of data science and machine learning tools.
Sure.
Anything else that pertains?
Sorry.
Sure, go ahead.
Oh, so I was thinking another question that Mr. Lober had was in the forecast line, are those confidence intervals?
Yep. So that's a really good question and a really important thing to comment on. It's kind of minute. Well, it's a seemingly minute detail, but it's actually really important depending on the application. Every prediction comes with uncertainty, and understanding the uncertainty is really key. So in this case, we're trying to understand these kind of peak periods of electricity consumption. And that's important for a variety of reasons. But one, if you're an electricity generator, you need to make sure that you meet the demand of the population. And if you underestimate what type of energy demand there's going to be, that puts a lot of strain on the grid and may cause blackouts. So you can't underestimate. And so having this kind of confidence interval is key to decision making.
Thank you, Dr. Willert.
And that applies to a lot of problems, not just energy forecasting. All right, so I'll move on a little bit. And as I promised, I'm going to use ChatGPT to help me give this presentation. So I asked ChatGPT specifically to help me create a slide that said, what is data science? And this is what it provided. And I wouldn't have included this if I didn't really agree with the results. So it encouraged me to add a subheader calling data science an interdisciplinary approach to extracting insights from data. So data science is this field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. So a lot of words there, but I'd like to highlight a couple of them. The key is really this extracting knowledge and insights from data. Being able to make decisions from data, be able to optimize processes, target the right customers, etc. That's the goal of data science in general. And two other things I'd like to highlight is this structured and unstructured data. So structured data is probably the type of data that most people think about. It's data that's in the form of a table. So you might have 3 columns, the name of a student, their age, and their GPA, for example. And each row would represent a single student. Unstructured data is exactly that. It's data that's unstructured. It could be in paragraph form. It could be in images. It could be in documents or invoices or contracts. It's really hard to tackle, but that is really where the next generation of AI is leading us. So again, the goal of data science, and this is a really good thing to remember, is to turn data into actionable insights that drive business value and support decision making. Insights aren't valuable if they're not actionable. That is, if we can't do something with it. And so data scientists use a variety of tools. They use statistics, mathematics, computer science, and they analyze, process, and understand data. These techniques kind of overlap a bit with the methodology, but we build predictive models, apply machine learning algorithms, design experiments, and use a variety of tools to, and I love this, the combination of words, uncover patterns in data. It's really what this is all about. And data science is a constantly evolving field. Every day, a new model or a new paper is written, and it really takes a lot of work to stay up to date. And increasingly, organizations are recognizing that they need to use data to make informed decisions and stay competitive in the marketplace. So getting into kind of the latter half of my talk, I wanted to talk a little bit about some of the skills that are required for data science. There are a lot of skills, and these are broad categories. You could obviously drill down into all of these and expand them into probably significant lists. But here are 6 kind of key areas which I think are really important. I've kind of grouped them into groups of 2. So in green are those that are math and statistics related. Having a good understanding of probability and statistics is really key for understanding a lot of algorithms. And you also need to have a good background in mathematics. So calculus and linear algebra are very helpful. Pretty much every deep learning algorithm relies on some variant of a technique called gradient descent, which optimizes the parameters. To implement gradient descent, even in its simplest form, you need both calculus and linear algebra. You need to be able to calculate derivatives or slopes of high dimensional functions and be able to do matrix mathematics with the outputs. In red are a couple of kind of computer science skills that are required. This is by no means all-encompassing, but you need some sort of programming skill, whether it be Python, R, or Julia, MATLAB, C#. There are tons of programming languages to choose from, and you can accomplish data science in really any of these programming languages, but some make it easier than others. Python is my language of choice. It has a really robust ecosystem of packages. So when working on on these data science projects, you never work from scratch. You always try to use an algorithm that somebody else has built first and apply it after curating your data set. That doesn't mean that it always works. You might have to tune it for your own needs, but we'd never make any progress if we had to reinvent the world every time. And Python has a ton of these algorithms that are easily at your disposal. SQL is really important. So this structured query language is a tool for getting data out of tabular data sets or tabular databases. Or another way to say this is relational databases, where different tables have different relationships with one another, and you can join these different tables to make new data sets. There are plenty of alternatives to SQL that are becoming more popular as more of our data is unstructured. So it's really kind of a core skill, but there are other skills that are necessary. And then finally in blue here, I wanted to highlight a couple of these soft skills that are really important. As I've said a couple times and will continue to say, data science is worthless unless you can present your results and make those results actionable or those insights actionable. One skill in which you really need in order to do that is data visualization. So the ability to make charts and graphics that explain the relationships in the data that you've observed and can help those decision makers to really execute those actions. You also need to be able to write well and communicate well, both for communicating your results, but also for understanding your problem. A data scientist cannot be an expert in every bit of subject matter. So for example, I work in the sustainability business. We help our clients buy energy across the globe. To be quite honest, I don't really understand that well how energy markets in, say, Norway work. But that's okay, because we have other experts that do understand that. And so we need to be able to communicate with them to understand their problems and provide solutions to them that satisfy their needs. The only way to do this is to be able to communicate well. And at the end of a project, you need to be able to document your results, defend those results, and make those requirements and recommendations very clear to business leaders. I also really like data science for a completely different reason. Data science has only been a really well documented career field for maybe 10 years, maybe even less than that. There have been people who had been doing similar things, but it really grew a lot in the 20 teens. And because of that, nobody was really getting a degree in data science or machine learning. There were some people at select programs that were, but most data scientists like myself have come from other places. And just here are a few of them that I've encountered throughout my career. So obviously for me, I'm in mathematics. I came from applied mathematics, but there are plenty of people who started in theoretical mathematics and have found their way to data science. Computer science is another big field that drives into data science, specifically because of the need to interact.
Yeah, dude, you should be ready. Huh?
Please mute yourself if you don't mind. Thank you. Really, any quantitative field which you're working with data and mathematics is a great starting place. I've worked with economists, engineers in a variety of fields. My last job, my boss was an aerospace engineer. Two of my employees, one was an electrical engineer, and one was an industrial engineer. So there's tons of ways that you can get into data science. Others have been trained in statistics or physics. One of my employees right now came from modeling weather and climate. So really, any of these quantitative fields can set you up for a career in data science and machine learning. So maybe I'll pause there again. Are there any questions, Shreyas and Shraman, that have been related to these last few slides?
There's one question. They're asking, in terms of obtaining a PhD in general, how does it differ from getting a bachelor's or master's?
Sure. So generally speaking, getting a PhD is a very narrowly focused research project. Starting with your bachelor's, well, let's even start with high school. High school, most students are required to take a really broad array of classes. You'll take classes in English and maybe foreign language and history, economics, chemistry, physics, math, maybe some computer science, different arts. You really try to prepare yourself to be a well-rounded person. In college, as a bachelor, in your bachelor's degree, you start to specialize. So you still take kind of your baseline classes in a variety of fields, but then you probably spend about half of your time in your degree field or your major. So for me, I think about maybe 18 of my 32 courses in undergrad were in the field of mathematics. Once you get to your master's program, you are almost entirely focused in that one career field or that one academic field, unless you do a degree that requires you to maybe span a couple of fields. Say if you're in biomathematics, you might take some that are in the mathematics department and the biology department, as well as maybe a tailored biomathematics department. For me, most of my courses in grad school were in the mathematics department, aside from maybe 4 to 5 classes that were in the nuclear engineering department. But that was actually maybe a little bit unique because most of my peers focused entirely in the mathematics department. The PhD isn't really coursework. The PhD is a research project, and it builds on all those skills that you've developed from your undergraduate degree and your master's, and you are really working to push the boundary in one very specific subset of your academic field of choice. So for me, in applied mathematics, I was working to develop new ways to solve a very specific problem in kind of the overlap between mathematics, computer science, and nuclear engineering. And so at that time, I was the foremost expert in the world in one very, very tiny sliver of academia. And that's really what the PhD is about. It's about pushing the boundary of human knowledge in a very specific field. So that was maybe a little bit longer of an answer than people expected, but that's really what the PhD is all about. Just being conscious of time, I'm gonna keep going, and then we'll save some time at the end for a few questions. So in the beginning, we Mr. Lober talked briefly about some of these terms like supervised and unsupervised learning. And this is really what I'm going to call classic data science and machine learning. So supervised learning is one thing that we do a lot of, and that's the task of learning functions or maps from an input to an output. So for example, performing a regression. So estimating a relationship between input variables and numerical outputs. So I've highlighted these input variables in blue and the output in red. So in my field, how much energy should a standalone 1,200 square foot retail store in Chicago, Illinois use on an annual basis? So I've got a few variables here. I know that this store is a standalone as opposed to being part of a mall, maybe. I know the square footage of the store. I know that it's in retail, and I understand that it's in Chicago, Illinois, which impacts things like weather. And I'm trying to predict a numerical quantity, probably the number of kilowatt hours that it uses in a year. It's a very simple example of a regression problem. In classification, I have similar sets of input variables, but I'm trying to determine which of the set of categories an observation belongs to. So in this example, I know that a credit card transaction occurred at an online retailer for $1,700, and it was executed at 3 a.m. local time. And here, I'm trying to determine whether the transaction was authentic or fraudulent. So this transaction belongs into one of two categories or classes, authentic or fraudulent, and I'm using the input variables to try to make that determination. Unsupervised learning, however, is a task where we're trying to discover patterns from untagged or unlabeled data. And so this is really about finding patterns in a set of data. One example of this is clustering. So grouping sets of objects so that the objects in the same group are more like each other than objects in another group. It's a little bit more difficult to come up with a simple example here, but it's something you can easily go read a little bit more about. There are more fields of data science and machine learning. A couple of them we'll touch briefly upon in the coming slides, but there are semi-supervised learning and also reinforcement learning. These labels start to blend together a little bit as these problems get more complicated. It's really hard to do any problem at all without doing some sort of unsupervised or supervised learning. Another thing that's really interesting and something that people interact with really on a daily basis is recommender systems. So this is helping users find content that they want or need. And this is something that is really big in business, right? So it's about helping keep your clients happy and getting them to spend more time using your service. So like Pandora or Netflix or with podcasts, they understand that you've watched X, Y, and Z, and they're going to recommend a few more shows that are similar in some way, or they figure out patterns between other people who have watched the same movie or listened to the same songs and recommend other things that they like as well. So this is a really cool field that helps drive a lot of business, especially in the online realm. So this is something that's been hinted at a couple times already, but I really believe that we're entering a new generation of data science and machine learning. And I think that the subheader here is kind of the key. Everything is data now. By no means is this slide all encompassing, but I tried to just give you some ideas of the wide breadth of data types that we have access to as data scientists. So these traditional data sources, databases, tables, spreadsheets, again, thinking back to the example, you've got a table that has a student's name, their age, their GPA. That's what I'm calling traditional data. As we get into more things that are unstructured, we've got documents and text, invoices, contracts, books, newspapers. All of these things have information and patterns that we can use to understand the world around us and make informed business decisions. There's also other multimedia sources. One of my bullets didn't get erased here, unfortunately. You've got images, video, and text 3. So text 3 is a typo here, but images and video are also sources of data and information. And then another category which I've labeled as internet generated, social media posts, shopping history, browsing history. All of these things give us information. It's amazing what's available in social media. Something as simple as a tweet can move the stock market. And those are relationships that can be really valuable to understand and take advantage of. So what's on the road ahead? So I can't really poll the audience here, but maybe in the chat real quick, who has heard of ChatGPT maybe before tonight, before it was brought up at the beginning of this talk? I don't know that. All right, so most people are saying they have. It's kind of an amazing phenomenon. This is the first time, maybe there was one more before this, where machine learning has really made the news. So, I noted here, remember that what is data science slide? It was written entirely by ChatGPT. This is amazing. This is a bot that, if you can connect to it, which I know is challenging at times, just because of the high demand, it can answer really, really deep questions, and is going to have implications across the business world very soon. And it actually probably already has. We've learned in the last few days that Microsoft is trying to incorporate ChatGPT or one of its variants into the Bing browser. Just a few days after that announcement, Google has announced their new chatbot model called Bard, B-A-R-D, which is based on their Lambda large language model. So there's just so much activity in this space, and it is only going to continue to accelerate. The CTO of a website that is used to host these large language models, the website's called Hugging Face. The CTO expects that there are at least 10 variants of ChatGPT by the summer of this year. Have people also heard about DALL-E and Stable Diffusion? These are other tools similar to ChatGPT, but instead of generating text, they generate images. Unfortunately, I haven't included one here. I should have thought about that, but you can ask it to create a photorealistic picture of a cat wearing a hat, driving a car. And you know what? It'll sure enough create one that looks pretty realistic. So DALL-E and Stable Diffusion, there are plenty of variants of this, have kind of taken the internet by storm as well. We start getting down into some new models that are less well-known, like VALL-E, V-A-L-L-E, which given a few seconds of voice recording, can be used to generate voice, generate a talk. So for example, I could have recorded myself for a few seconds. I could have created a script, and I could have asked VALL-E to read the whole script in my voice, and I could have gone and eaten dinner while all of you were listening. I should have done that, actually. I'm a little hungry. There's also a new one called Music LM. This is a model which, given a short description, will generate music in the style of your choosing. So generative AI is booming. All of these things that I've talked about on this slide have happened in the last year. So just imagine what can be done in the future. This is only going to continue to accelerate. I notice we're getting close to time, so I'm gonna try to skip ahead a little bit. Reinforcement learning is another topic that's really cool. This is where we're teaching machines to act. So these agents learn by interacting with an environment. It gets to observe the state of that environment and choose an action. And it's given rewards for choosing good actions and penalties for choosing bad actions. And as it trains, generally in a virtual world, it learns to make these optimal decisions. So this technology is being applied in a variety of fields. So smart EV charging for charging electric vehicles, algorithmic trading of stocks on the stock market, trying to cool data centers in an optimal way. This is there's an article linked here by DeepMind, who's trying to save energy costs and reduce carbon emissions by cooling data centers in a more intelligent way. Traffic light control to try to reduce traffic, especially in those kind of high intensity traffic periods. If you're interested in plasma physics, specifically for fusion experiments, there's an article about magnetic control of tokamak plasmas through deep reinforcement learning. There's autonomous driving, which is another really interesting field, and something that a lot of you have probably seen already. You know, these robots that have been developed by companies like Boston Dynamics, or in this case, MIT, they've taught a machine to learn from scratch. They haven't given it any rules. They haven't programmed it to understand what to do with its legs. They just give it options, and through its environment, through trial and error, it learns, which is quite amazing. So just to kind of wrap things up here, the career outlook for data scientists is amazing. It's unlimited. Demand right now is unlimited for data scientists or machine learning engineers and AI experts. Organizations across the globe need assistance in getting access to these insights from their data to make informed decisions. The salaries are good as well. In the US, new graduates are making over $100,000 on average. And I mean, that's a great salary. Obviously, this varies greatly based on company and geography and skill set, but it's a good skill. It's a good paying job. And the careers are very diverse. Really, whatever you're interested in, you can marry with data science. So if you're interested in healthcare or finance or energy or the climate, government, service, sports, entertainment, education, gaming, you know, anything, biology, there's opportunities everywhere. And then kind of going back to one of those questions that was asked earlier, education is key here. This field keeps changing. I don't think that everybody in this field needs a master's or a PhD. I didn't plan on becoming a data scientist. If I had, maybe I wouldn't have gotten a PhD. I don't know. It's a great thing that I have it. I love that I did it, but I don't think everyone needs a PhD. On the other hand, you do need to be willing to learn really every day for the rest of your life, because this field is changing fast and you need to continue to upskill to stay up with the times. And everyone on my team is really expected to spend at least 10% of their time at work learning each week. So this isn't optional. You have to continue learning if you're going to continue to make an impact in this field. And I think a good way to wrap up is on a little bit of a lighter note, asking the question, artificial intelligence dangerous? My answer to that is AI in itself, I don't think is dangerous. Humans who use AI the wrong way might be dangerous. Here's a quote from Stephen Hawking. The development of full artificial intelligence could spell the end of the human race. It could take off on its own and redesign itself at an ever-increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. I don't know that I necessarily agree with that, but I worried about some of the kind of ethical challenges that will arise, some of the societal challenges that arise as certain jobs become unnecessary as AI can do them. But on a lighter note, I like this this kind of comic on the right. So they're looking at robots and they say they don't appear to want to take over; they just want to dance. And ironically, we've seen some robots that have been built by companies like Boston Dynamics that are actually quite good at dancing. So with that, I'm going to end my talk. I'm going to stop sharing my screen. I recognize that I left a slide on there at the end from a different presentation that I shouldn't have. But yeah, are there any other questions that we want to get to before people start to leave?
Yeah. Thank you so much, Dr. Willert. I really enjoyed the talk, and I'm sure all the students here did too. So it looks like we have quite a few questions in the chat. So the first one is, what do you do in your typical workday as a data scientist? And is your job remote, in person, or hybrid?
Yeah, so for me, my job is hybrid. I spend 2 or 3 days a week in the office and 2 or 3 days a week at home. And I think that's a great balance. I get to spend a couple days interacting with people, having meetings, understanding the business challenges. And then I have a couple days at home where I get to, focus and do more technical work. As a manager, I don't get to do as much technical work as I used to. For kind of a junior data scientist or a senior data scientist, I'd expect you to spend, 30 hours a week doing technical work, maybe 5 hours a week learning, and another 5 attending meetings, understanding business problems, documenting results, etc. As you move up in your career, you have to start thinking about other things like business strategy and people management. So I do a lot less technical work than I used to, but it still probably represents about 20% of my job.
I see. That makes a lot of sense. So another question that someone had was, so when you're discussing generative AI, how is that different than more traditional models that a lot of students here are familiar with, like linear regression, for example?
Yeah, that's a deep question. So generative AI is a really cool and novel field. One way that it's different is that a lot of these generative AI models are built on top of what are known as large language models. And these large language models are generally trained and built, at least initially, with a technique known as self-supervised learning. So I can't spend too much time getting into it, but you might have a sentence like, I love doing data science. And instead of just asking it to predict the next word, you might erase a word from the sentence and ask a model to try to predict what that word is. So it might say, I love blank science. And the models have to learn relationships between these sentences, likely the sentences around it, because, I could have said, I love material science. I love medical science. But if it knows some more context about me, it can infer that that missing word is data. And so this is like a field called masked language modeling, and is really kind of one of the key ways in which we can train these large language models. After that, ChatGPT was trained using a technique called reinforcement learning with human feedback. So basically, ChatGPT was given a prompt, something like, can you explain data science to me? And ChatGPT was asked to give 3 or 4 responses. And then a human labeler looked at those 3 or 4 different responses and ranked them from best to worst. And that ranking ended up creating a reward model for ChatGPT to learn on. So it could learn then, with its knowledge of language, also what type of responses do people enjoy or rank highly. And it continued to loop over this process by creating more responses, which would then be graded. It's a complicated process, but it's really, really fascinating. I see, another question just came up about AI in the medical field. There's a ton of different ways that AI is being used in medicine right now. Shraman and Shreyas can tell you some things about that from work that they've done themselves. But one thing that you can do is use vision models using convolutional neural networks to look at X-rays or CT scans and try to identify disease. People are using AI to model new drugs for drug discovery. So new ways to treat illnesses or diseases that have been plaguing humanity. So there's really no limitation. And techniques like regression, clustering, and even large language models can be used to aid in the medical community. So it's really only limited by our imagination. Shreyas probably knows more about AI in medicine than I do at this point. He's the expert now.
Yeah, thank you so much, Dr. Willert, for answering all these questions. I guess, do you have any more time to answer a few more?
Yeah, I can hang around for a few more minutes.
Sure.
Yeah, and one question someone asked is Community AI willing to mentor any student projects that are into AI? And I guess, yeah, definitely, right?
Yeah, we would love to. Yeah, just send us an email at team@thecommunityai.org, and we would definitely respond, and we can figure something out from there.
Sure, yeah.
So I guess maybe one last question before we leave for the day is, see, I found a question here before regarding big data. So what do you think are some of the biggest challenges when working with big data? And I guess in your personal experience, what were some challenges you had and how did you overcome them?
Yeah, so, data science is something that I could easily have done a 3-hour talk on. Some of you probably would have fallen asleep by the end. But big data is an interesting field that is actually maybe one of, to me personally, the least interesting subsets of data science. Because big data is really about data volume. It's not necessarily about being as creative with algorithms. And this is probably, I probably shouldn't say that. I'm probably a little bit biased. But big data, the challenges are generally about how to perform computations quickly on really large data sets. So for example, Facebook or Twitter or Amazon, they just have tons of data flowing in at every moment in time, and they want to have strong models. So how do they balance building complex models and generating value? So recommender systems are a common field where this is important. The way to deal with them is to have really talented computer scientists and data engineers on your team that can help perform these computations efficiently on the right hardware, which is a really interesting aspect of data science and machine learning is the interaction between the algorithms and the physical hardware that you get to work with. So GPUs, large compute clusters, cloud computing, sometimes just throwing bigger computers at a problem doesn't actually speed it up. You have to be smart and efficient with the way that you process data, the way you collect it, whether you choose to write it to disk or keep it in memory. There's a lot of various challenges that come with big data. Like I said, I'm more interested on kind of the modeling side, probably because of my background and understanding the patterns and relationships. But there's no doubt a need for us to have expertise in, in the algorithms, in the hardware, in the models, in the feature engineering, where all of these things kind of come together and generate business value.
Awesome. Yeah, thank you so much, Dr. Willert, for the talk and for answering all the questions. So I personally really enjoyed the talk, and I'm sure all the students here did as well. Thank you so much.
Yeah, thank you for having me.
I guess I can stay for a few minutes after, just so we can talk and just catch up.
Hey,
Yeah,
Dr. Willert. My name is actually Praseet, and I'm also a member of AI Club. And I thought this meeting was really valuable, and I think all of us found it valuable. So I just want to thank you for that.
You are very welcome. This was fun, and I'm always happy to interact with members of the Manual AI Club and partners of Community AI. So